Hello, I'm Miles Tails per hour. We will learn about simple harmonic motion. Simple harmonic motion is a special type of periodic motion where the restoring force on the moving object is directly proportional to, and opposite of, the object's displacement vector. In every nature, simple harmonic motion is always oscillatory, like motion of the hands of a clock, wheels of a car, pendulum, spring, and others. This can now be depicted in the graph. You can see that the sine wave is changing. There can be of two types, linear simple harmonic motion, and angular simple harmonic motion. In linear simple harmonic motion, suppose this is a cube, or could be a bob attached to the spring. It therefore goes up and down if it is supported from the top. This is due to its gravity. When you pull downwards, the spring elongates. And once you release it, the spring will take back and forth vertically, until it reaches the mean position. If it is horizontal, then this can be done on a frictionless surface. The formula is given by, force equals minus k times x, where k represents as a constant in the spring, and x denotes as a distance where block has moved. The negative sign on the spring's force means that the force exerted by the spring opposes the spring's displacement. This is called a Hooke's law. The units for the spring constant, K, are newtons per meter. For example, to find out the spring constant, let's suppose F is given by 5 newtons and x be 2.5 meters. Thus, the spring constant is 2 newtons per meter. On the other hand, called angular simple harmonic motion, it involves to and fro angular oscillation of a body about a central position or orientation. For example, a pendulum of a clock, or its disc rotating to and fro, depending on its angle theta. The rotation of the disc is typically called the torsional pendulum. The restoring torque is given by Greek letter tau, equals, minus Greek letter kappa times theta, where kappa denotes as a torsional constant. Deriving the expression into time period of simple pendulum, equals 2 pi times square root I by kappa. I denotes as a length of string, and kappa as acceleration due to gravity. This can be also replaced to L and G as well. The equation must be still valid. If the length of pendulum rod is too small, it will oscillate quickly, and if it is quite longer, it will slowly oscillate. So, this is just basics of simple harmonic motion. Like, comment, and subscribe now.